Okay. We are going to start with this picture right here. These two lines are parallel. What are some things that you notice? Joey?
The lines are not touching each other.
Okay, they're not touching, which is why they're parallel.
And no matter how far they go, they will never touch.
Okay, Theo?
They have the same slope.
Did anybody else notice that? And A, is that true?
Sort of.
All right, well, let's look. If I look at, okay, here is a coordinate. Here is a coordinate. Here is a coordinate.
That's up to right 3.
So we're going up 2 over 3. Up 2 over 3. So our purple, hold on, Joey. Our slope for the purple line is 2 over 3, right? Okay. If I look at this red line, we go up 2 over 3. Uh-oh. Is Theo right?
Yes. They wouldn't be parallel if that wasn't.
Theo says they wouldn't be parallel if that wasn't true. Okay, so parallel lines, you are telling me, have the same slope. Okay, these two are perpendicular. What do you notice about this picture? They cross, they have an intersection. The intersection is at the y-intercept, but that's not always going to happen. That's just a special case, okay? The slopes are different. Did anybody look at the slopes? Do you think we should? Okay, purple slope is what? Okay. And the red slope.
It is 3 over 2. Negative 3 over 2.
What do you notice? It's what? Okay, Zoe says it's inverted. Connor is not raising his hand. Okay, what else is true? So 1 is 2/3. Zoe says they're inverted, but what else?
They have an intersect point.
Yes, true. Joey?
1 is a negative, 1's a positive slope, 1 is a negative slope.
One's a positive, one's a negative,
And both of them
and
connect.
their upside, like their fractions are what Zoe said, inverted. Okay. Theo?
And all the lines are linear.
This is true. It's why they are lines. Okay. Ella, did your contribution get taken away?
Yeah.
Okay. Could you please turn to page 108? Savannah, if you still need to go make it. Okay. So what we need to write down is we need to write down that parallel lines have the same slope. Okay. And what we noticed about our perpendicular lines, one slope was positive, one slope was negative, and their fractions were flipped. Okay. So we call that opposite reciprocal. Okay. Opposite meaning one's positive, one's negative. Reciprocal means we're taking that fraction and we're flipping it upside down. So in our warm-up, well, in our talk about it warm-up, one slope was 2/3 and one slope was -3/2. They are opposite reciprocals. Okay. So our goal today is to be able to determine when we have parallel lines, when we have perpendicular lines. Okay? And we're going to have to be able to do that in a variety of ways. Can we look at lines on a graph and determine it? Can we take 2 points from some lines and determine it? Can we take an equation and determine it? Okay. The only thing that matters is that our slopes are the same for parallel lines and our slopes are opposite reciprocal for perpendicular lines. So let's focus on parallel lines first. What I'd like you to do is go to that next page, and in number 1, I would like you to determine the slope of each of these 3 lines. So the slope, so like what I would do is like line A has a, that's not line. Line A has a slope of, figure it out. Line B has a slope of, figure it out. Line C has a slope of, figure out those 3 slopes. So we can figure out if we have anything that's parallel. All right, what's the slope for line A?
3 over 1.
Okay, 3 over 1. If you're at 3 over 1 means 3, same thing. Okay, what about B?
4.
And what about C?
4.
Okay, so we can say that line B is parallel to line C because they have the same slope. Yeah? All right, so now in example 3, because we're going to skip number 2, in example 3, we have the same thing happening except we don't have the graph. So what are we going to have to do 3 times? Find the slope. And I don't need the equation of the line, I just need the slope, okay? So this is what I'm going to do. If you are in either the blue or the red group, you're going to find me the slope of this line. If you are in the green or the teal group, you're going to find me the slope of that line. If you are in the yellow or the purple, you're going to find me the slope of that third line. Okay? I just want the slope. y2 minus y1 over x2 minus x1. Why aren't you finding it? Okay, we have this one. Use that one. All right. Red and blue. Do we have a slope? What do we get?
2.
2?
Yeah.
I got 1/2.
So we're taking y minus y over x minus x. So you should get 3 over 6. You accidentally reversed it. That's okay. That's why we're doing this. Okay. All right. Line B, green and teal. What'd you get? 2/5. And then line C, yellow and purple. 1/2. So I want everybody to write down that line A has a slope of 1/2. Line B has a slope of 2/5. And line C has a slope of 1/2. Do we have any lines that are parallel? Line A is parallel to line C. Okay, now we are going to do 2 more problems on this page, but before we do that, let's talk about some lines that are perpendicular. So what I want you to do, excuse me, what I want you to do is turn to the next page. Okay, and I want you to find me the 3 slopes for number 10. All right, what's our slope for A? Just up 3 over 1? Okay. What about for B? Ooh, I'm hearing, negative 2 over 6 would reduce down to what? Negative 1/3. Interesting. And then line C looks like 5 over 2? Okay. So, do we have any slopes that are the same? So we do not have any parallel lines. I don't think that surprises us just looking at the picture. Do we have any slopes that are opposite reciprocal? Okay, so if we think of 3 as 3 over 1, these 2 slopes are reciprocals and they're opposite. One's positive, one is negative, and the 2 fractions are just flipped upside down. So we can say that line A is perpendicular to line B. So this is our shorthand for perpendicular. Are you okay if I write that instead of the really long word?
Yeah.
Okay. I don't want to write the really long word. I might misspell it. Okay, so I want to get one more practice at finding slope. So we're going to do this same kind of thing. Okay. I would like the purple and red group to find the slope of line A. I would like the yellow And we're going to go teal group to find me the slope of line B. And then I want the green and blue group to find me the slope of line C. We're going to practice this one more time, finding slope. We're going to determine if we have some perpendicular lines or not. Check in with your neighbor just in case. All right, line A, what's our slope?
-1.
Negative what?
Oh, no.
Just negative 1? Yes? I don't know why I'm looking at, I'm sorry. Negative 1? Yeah.
I got negative, I got 5.
Okay. So let's take 1 minus 4, right? Over 1 minus negative 2. So which is 3 over, negative 3 over 3. Right? Yep. Which is negative 1. All right, slope B. 3 over 3? 3 over 2. And teal table, we agree with that, 3 over 2? Okay. And then my blue and green group. Huh? All right, we better do this. 4 minus negative 2, negative 1 minus 1. So we have 6 over negative 2, which is negative 3. Oh, this was so disappointing. Do we have any parallel lines? No. Do we have any perpendicular lines?
No.
This was a bummer. Boo. Nothing special. I didn't even know that was going to happen. All right. All right, so let's flip back to the page previous, and I want to go look at number 6. How the heck am I going to be able to tell if I have parallel lines here? If we have an equation of the line, what's the one way we can figure out what the slope is? And what were you going to say, Aubrey? You were going to say get y by itself, right?
Yeah.
Because if we have y equals mx plus b, then we know exactly what the slope is. And in order to get y equals mx plus b, we would have to solve for y. So, line A. If 5y minus x equals 4, how do we solve for y? We're going to have to add x, right? And I'm going to write this as 5y equals add x plus 4. Because I'm going to really want my x to come first, since we want this to be in y equals mx plus b. Now, what is my next step to get y by itself? These are like little puppets. Divide by 5. Okay, now, let's rewrite this so that it looks like y equals mx plus b. So I can take x divided by 5, and then I can take 4 divided by 5. Now, question, should I write it as x divided by 5, or what's a different way I could write that?
1/5 x.
I think writing this as 1/5 x might help us more figuring out our slope. Plus 4/5. Luckily, we don't have to graph this. I really don't want to graph it because the y-intercept is 4/5. Okay. All right, so there's line A. Ooh, line B doesn't look as bad, does it? Let's talk about line B. We have 5y equals x plus 7. That's not bad because what's the only thing we have to do? The only thing we have to do is divide by 5. Okay? To get y equals, again, x divided by 5. I don't think writing x divided by 5 is going to help us as much as saying, okay, hey, there's a coefficient of 1 with the x. Let's write 1/5 x plus 7/5. I like that. Okay, I'm going to give you a moment to put line C into slope-intercept form for me, please. Solve for y in line C. It's cool if you talk to each other about it. I hear some people comparing answers. That's good, that's good. Okay, what's the first thing that you did? Add 2x. So do you have 5y equals 2x plus 5?
Yes.
And then we had to divide by 5 in order to get y equals 2/5 x plus 1?
Yes.
Okay. Do we have parallel lines? Line A is parallel to line B. Is that what you said? How do we know that, Dot?
Because they both have the slope of 1/5.
Ah, both line A and line B have a slope of 1/5. They have the same slope, so our lines are parallel. Hey. Okay, we're gonna do some more teamwork. Are you okay with teamwork? Okay, I'm gonna get really annoying with the page turns, but you're gonna get over it. Okay. Actually, we are not gonna need teamwork. Let's just go to 14 quick. And do you notice how B and C are already in y slope-intercept form? So I just need you to get y by itself here. Is this for Miss Judson?
Yes.
There you
Oh, I thought it was going to be big stuff.
go. I know. Sorry.
I think we should figure out whether they're parallel by just graphing them because I couldn't tell with the MX form.
Well, as long as they have the same slope, they're parallel. So like when we were over here, Joey, do you see how 1/5 is our slope for this line and 1/5 was our slope for this line? So I can see that the slopes are the same. Okay. only to be ready for the quiz? Okay, so I'll have you turn that in. That was the green is a graded assignment, so you'll need to turn it in, okay? But I don't think you've done it fully because can I see it? On these, I'm asking for, right, on all six of these, I need y equals mx plus b. So we're gonna need to find the slope, and then, like, so.
Equals mx plus b. What's that? Y equals.
So, slope intercept, okay. So this might be a time where, looking at the notes for 4.1 might be a good idea, okay? Okay, what'd you get?
X plus 1/5.
Do you have 2/5 x plus 1/5?
Yes.
Because you added 2x, right? And then divided by 5. Okay, so looking at this, do we have any perpendicular lines?
No.
No, it's close though, right? We have 2/5, 2/5, and 5/2. If this were, what would this need to be for these to be perpendicular? This would be a -5/2. So instead, all we know is that line A is parallel to line C because they have the same slope. I'm kind of striking out in my examples here, aren't I? All right. Annoyingly, flip back to this page. I'm sorry. Okay, now, I like this, and I think you won't mind it, but we need to be able to write the line of, let me back up. We need to be able to write the equation of a line parallel or perpendicular. So, in number 7, I'm giving you a point, 3, -1. And I want our line to be parallel to this guy right here. If our line is parallel to that guy right there, what do we know?
Our slope has to be 1/3.
Say it louder.
Our slope has to be 1/3.
Our slope has to be 1/3. Why is Aubrey saying that?
Well, it's
Yeah. To be parallel, we have to have the same slope. So we know that our slope has to be 1/3. Okay. Miles, this is what we did. Okay. Y minus y equals slope times x minus x. Okay, we can just use our point slope form to help us get there. Here's our point. We picked out the slope from this. Okay. All right, so what do we have? Y plus 1 equals 1/3 x. What does that equal? What's 1/3 times -3? Okay, -1, right? Then we need to subtract 1 to both sides. So y equals 1/3 x minus 2. Okay. I have a question for you. Are you somebody who likes to have options?
yeah.
Some of you say yes, some of you say no. Okay. We're not going to do number 8. I want to show you a different way that you could write the equation of a line given a point and a slope. Okay? Because sometimes I think it's good just to have like multiple ways of solving for something. So our goal is to have y equals mx plus b. Do you agree?
Yes.
Okay. So we can use point slope form, or what we can do is we can use the point and the slope and just solve for our y-intercept. So let me show you. Our slope is 1/3. our point is negative 1, 3, and we don't know what our plus b is. I did a terrible job. What goes there? What's the x? 3. And what's the y? Negative 1. I got distracted by some people who are being a little distracting. Okay, so hey, watch what happens. I have negative 1 equals 1 plus b. So what's b? So b is negative 2, right?
Oh, yes, it is.
So y equals mx plus b. Oh my goodness, we got the same answer. That's so crazy. Okay, I want you to just know that if you don't like point slope form, you could just do slope intercept form, and that's the only thing you remember, and just solve for b. Okay. Does anybody feel like, man, I really like that way? No? Nobody likes that?
No.
Well, fine. Okay. I'm not going to go all the way through number 15. Yeah, sorry, turn the page. I don't know if we have time. Maybe we have time. We have time. We can do it. Thanks, Tinley, for the encouragement. Okay, if I want to be perpendicular to this line, what's our slope for our new line? Negative 3 over 2. If I want to be perpendicular, I want opposite reciprocal slopes. So, y minus y equals slope times x minus x. Are we okay with that? So, we get y minus 2 is negative 3 halves x. What's negative 3 halves times 2? It should be minus 3, shouldn't it? Because negative times a positive is a negative. So then we add 2 to get y equals negative 3 halves x minus 1. Okay,